Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good evening to all of you. Okay, welcome back to our class. Okay, for this video, we will discuss the exercise 4, which is just like the exercise number 2, but for this time we consider the AS prime. Okay, the existence of AS prime, which is the still for the still for compression reinforcement. Okay. So can we do it together? Shall we do it together? So I will change the value first. Okay, let's say we have 300 mm of B. The D is equal to, let's say, 550 mm. The D prime is equal to 60 mm. Okay, overall depth is equal to 600 mm. Okay, let's say the AS provided here is, let's say, 4H16, and then AS prime provided is 4H16, and AS provided is let's say 5H20. Okay, the concrete grade is grade 30, and the steel is 500 Newton per millimeter square. Okay, you can have 1 minute to write down this data. Okay, write down the data now. Okay. Okay, have you finished?
Yes, Doctor.
Okay, done. Okay, thank you. Okay, I want to ask you the question of what is the AS provided for 4H16 and what is the area of steel for 5H20? Okay, 4H16, what is the area provided? Anybody can tell me? Do you have a table?
X04.
Okay, good. Okay, good. 804 mm square. How about this one? 5H20?
1571.
1571. Okay, thank you. M square. Okay, so let's work together. Okay, I will like this one. Okay, so this is the task number 4, exercise number 4. Okay. So exercise 4. So the solution is just like this one. Okay, just like our previous case is you have to determine the distance to neutral axis. Okay, so you have to the distance to neutral axis x. Okay, I believe you still remember that in our previous example, which is exercise 2. So this is the stress blocks. Okay, and this is the for steel. So this one is the let's say in red color at the center is this one F. Okay, from the forces. Okay, forces inside the concrete due to compressions, and also we have let's say I use another color. Okay, forces inside the steel for compressions. Okay, we have FCC, FSC, and then we have forces inside the steel due to tensions. Okay, so in order to achieve the equilibrium, okay, and this condition, we have the compressions. The compression reinforcement are required only at what? Are required only at what? Okay, mid-span, support, or cantilever. This situation, okay, where we need the compression reinforcement. Anybody can answer? This is our last class lessons. Compression only where? Where is the position of inside the beam? Where is the position where we need the compression reinforcement?
Above
Sorry?
the column, doctor. Above the column.
Above the column.
For example, now we have the column and the beam is resting on the column. The compression forces act on top of the beam when it's sitting on the column.
Okay. So okay. So this one, maybe you can recall back to these notes. Okay. Maybe you can recall back to these notes. About the compression. Here is the okay. This one. Where is this one? Okay. So this one. Okay. Where is the compression? Here is the compression. Here is tension. Okay. Tension. Tension. Okay. And then the tension is at the middle. Compression at the top. Okay. This one. Compression. So we need at the mid span. Okay. At the mid span. So these situations only occur at the mid span. Okay. These situations, I mean, to achieve the equilibrium, okay, you must ensure that the forces, okay, the forces of this one, okay, the forces of steel, okay, forces inside the concrete due to compressions, okay, C is concrete and this C is compressions, plus, okay, I use color, okay, I better use color. Okay, the color, red color here is this one. Okay, to represent this one. Forces inside the concrete due to compressions. Okay, plus this one FSC plus forces inside the steel S for steel due to compressions must be equal to FST. Okay, forces inside the steel S for steel due to tension. So FCC, I believe you know the FCC is equal to, okay, we recall back forces, pressure is equal to forces divided by A. So forces is equal to pressure times A. So pressure is the, okay, 0.45 FCK. Okay, like in this notes, okay, I just write it down, right again, 0.45 FCK times B times X. Okay, this is X, the whole is X. This is B. Okay, I hope you still remember. Okay, and then plus FCC is equal to 0.87 FYK. This is the pressure, and then the area is, of course, area of steel. Okay, S prime. Okay, S prime. This is for compressions. So it must be equal to FST is 0.87 FYK. This is the 0.87 Fyk is the pressure, okay, the pressure, the stress times As. Okay, times As. Okay. Okay, so we must write down the equations. We must bring the value of x alone like this one. Okay, so how to do it? Simple. Okay, 0 point. Okay, let me use similar color now. Okay, light blue. Okay, 0.45 FCK. This is how to derive. This is how to derive the equations. Okay, x equal to 0.87 FYK time AS. Okay, minus this one. Okay, minus this one. Minus 0.87 FYK AS prime. Okay, minus the simple mathematics. So we can simplify. Now the value of x is equal to, okay, 0.87 FYK times, okay, this one, okay, this similar, the simple mathematics minus AS prime divide by this one. Okay, you bring it down, 0.45 FC FCK kan, FCK, this one is FCK times B. So what is the value of our x now? Okay, equal to 0. Sama kali lah ya, 0.87. Our FCK now, FYK is 500. Okay, AS prime, what is AS? Our AS, this one, AS is equal to 1571 minus 804. 804 is here. This is, okay, the AS prime, our AS prime. So we divide by, okay, divide by 0.45 times the FCK is 25 times B. What is the value of B? 300. Okay, B is 300. Okay, so what is the value of X now?
FCK is 30, right, doctor?
Oh, 30. Sorry. Okay. Okay, the 30. So this one is 30. Thank you. Okay, 30. So what is the value of X now?
82.38.
Sorry?
82.38.
82.38. Okay. Okay. So that's the value of X. Tak rasa kecil sangat ke? Betul ya, yang lain semua dapat value sama tak?
Sama-sama.
Sama Okay,
Doktor.
good. Okay, so and then the next the second step is we calculate the moment of resistance, MR. Okay, so like this, our previous case of case number 2, let's say, okay, this one, this is case number exercise 2. So this is our Z. Okay, this is our Z. Okay, you can simply remember that and understand the concept. Okay, so this is our FCC. So this is our this is our FCC here. Let me do it properly. This is our FCC. Okay, red color red color. Okay, red color. Okay, this is our FCC. Okay, the center. Red color, sorry, red color. FCC. So this is the level arm here is our Z. Our Z. Okay, and this is our FST. Okay, so this is our what we did in our exercise number, exercise 2. If you still can remember, exercise 2. Okay, M is equal to FST. Simply we do FST multiplied by Z. FST multiplied by Z. However, since we have the another one here, which is the what color? Okay, we have the FSC here. Sorry, FSC. Okay. Sorry, it should be upper. If I'm not mistaken, it should be higher. Okay, FSC is higher here, somewhere here. Okay, this one, this is the D prime. This one is FSC. Okay, so we take the bending moment. Why not we take the bending moment is from here, the forces of here up to here. Okay, this is okay. This is the value now. Okay, we take the bending moment. Bending moment is equal to moment of resistance is equal to FCC times F. Okay, FCC times Z1. Okay, so times Z. Okay, and then plus, okay, plus the FSC times the Z1. Okay, so it's equal to FCC. Refer back here, FCC is equal to what? 0.45 FCK. This one is FCK times BX. Okay, so like this one, Z and Z1. Okay, Z1 is here. Z1 is here. Some from here, the yellow color. This is Z1. Z1. So here to here is D. So here to here is D prime. So that's why Z1 is equal to D minus D prime. So because we want the distance from here, the center of steel for compression to the center of steel for tensions. Okay, D minus the D prime is equal to Z1. Okay, so FCC is equal to, okay, just a simple 0.45 FCK times BX, this is the FCC, times Z. Z is equal to, okay, as usual, as our previous, Z is equal to D minus 0.4X. Okay, this one, D minus 0.4X. Okay, times, okay, D minus 0.4X. Okay, so this is our Z. Okay, D minus here. This, okay, this is 0.4X. Okay, 0.4X. Okay, so we get the Z. Okay, the green color. Okay, and then plus FSC is equal to 0.87 FYK times the S prime. Okay, we deal with S prime because this is the steel for compressions. S prime times S primes times the Z1. Z1 is equal to D minus D prime. Okay, so equal to, okay, 0.45 FCK is equal to what? 30 times 300 times X. What is the value of X just now? 82, 82.38. 38, okay. And then D is, what is the value of D? 550, okay, 550 minus 0.482.38. Okay, and then plus 0.87 times 500 times 804 times 550 minus 500. Okay, the D is 50, D prime is 50. Okay, so what is the value? Anybody have the answer?
Three, 4, 7
347. Unit is?
kilometer.
Okay, good. Kilonewton meter. Everybody got the same answer?
Yes, doctor.
Okay, good. Thank you. So I'm leaving you with exercise 4A to 4D. Okay, I will share in the WhatsApp group this exercise and you have to submit as soon as possible. Okay, before next Monday lah. Before next Monday. Lama sangat ke? Okay je. Okay lah kan 4 hari, 1 hari buat satu. Okay, before next Monday by 12 PM. Okay, before next Monday you submit 4D, okay, 3A to 3D, and you submit the 4A to exercise 4A to 4D before next Monday by 12 PM. I will provide the Google form, okay, to upload later. But for today, you have to submit the exercise. You have to submit the exercise 3, exercise 4. What we did together. You have to scan and submit in the Google form. Okay, before I give you before 6. Okay, before 6 to upload. Okay, anybody? Anybody have a question? Do you have any questions, class? Okay.
No
Okay,
question,
thank you.
doctor.
Okay, thank you very much.